Hello guys, welcome, and this is our lecture 3 of our Cybersecurity Analysts course. In this course, or this lecture rather, we're going to be looking at network intrusion detection systems, firewalls, sniffers, and configurations. One thing we know from the very last lecture, from our last lecture, was we looked essentially at building networks using the Cisco packet tracer. However, we did not take a look at how to essentially configure a network so that it allows communication between the two. So the first thing we're going to do firstly, before we try anything else, is to look at how to configure a router. Okay, so I'm going to open up my Cisco packet tracer. Okay, and then we're going to take a look at how we can configure a router to allow communication for all devices across the network. Which we saw that devices can communicate using IP addresses, and IP addresses can be given dynamically or statically. And we're going to be looking at the static part of getting the IP addresses for the devices. Okay, so firstly, I'm going to build a network that is quite similar to the New York and Tokyo problem that we had before. So I'm gonna make use of generic PCs. We had like about 3 generic PCs or so. Okay, so I'm gonna have 3 PCs, give or take. Okay, 3 PCs, and then I'm going to have a router. Okay, and I cannot connect these PCs directly to the router. I need a switch. Okay, so I'm going to make use of this switch. Okay, and the connections are very much the same. We'll let Cisco automatically choose the correct cable. So there we go, and that's like so. Okay, and then we have this go directly into the router. Okay, and we recall that routers are normally placed between networks, so they are a jumping gateway between networks. So from this router, I'm going to have another network right there. So to do this part, not exactly a big deal. Something similar to the other branch. So here I'm going to have a switch, and I'm going to have PCs as well. So I'm going to have that PC, and I have this PC, and say another PC. So say this generic PC as well. Okay, I'm gonna take those, connect them across, just like I did with the other branch, PC to switches, like so. Okay, and then I have a cable go directly to the other router. Okay, then now what's gonna happen is we're going to be having communication that runs from this network to that network through this router. Okay, so this part can't exactly be a big deal. You can notice that we have these red symbols that we have there. That is due to the fact that we need to configure this router to allow traffic from this side to this side. Okay, so we have seen that this is an individual network, and this is an individual network as well. Okay, so we need to connect these two networks together, and we need to assign IP addresses to each of those devices in those networks. So what I'm going to do now is I'm going to open up the router. Okay, I'm going to open up this router and then configure that router like so. Okay, so let me use this. Okay, select that router. So I'm going to go straight into the configuration mode. And then in some cases, it will ask, do you want the initial configuration dialog? I'm going to say no for this, and then enter to get started. You'll notice that the prompt is going to be on router. Okay, so to begin your configuration for your router, you're going to first enable the router. Okay, I'm going to enable it by saying en to enable, or you can write enable in full, either way. Okay, and you'll notice now it shows this hashtag. Okay, once you're done, you're going to specify that you want to configure configure using the terminal, or you can say config T in short. Either way, I'm going to say configure terminal. Okay, so I'm specifying that I would like to configure using the terminal. Okay, once that's done, I'm going to select an interface that I would like to edit. Remember, I've got 2 interfaces, this interface and that interface. Each of them are going to individual networks. going to select this interface which goes to this network and configure that one. You'll notice that the interface is on GIG000. If your packet tracer does not show this name, then you might have to change this in your preferences. So you'll just go into Options, Preferences, and make sure that it's on Always Show Port Labels. This should be turned on. Okay. Now mine is checked, so it does actually show that. Okay. Back to the router. Okay. So now I'm going to select this one right there, because I would like to configure this network. Okay. So to do this, we have to then select that interface. So I'll say interface. Okay. And then GIG, which is the name of that interface, GIG0/0/0. Like so. Perfectly fine. You'll find it's going to change into config IF. Okay. Then I'm going to assign a gateway IP address for this side. Okay. In other words, what do these computers recognize this router as for that network? Okay. And to do that, I'm going to say IP address. Okay. Then I'm going to give that gateway an IP address 192.168.1. And normally the last piece we actually give is a 1 for gateway, so we'll keep it like so. Okay. And then you need to give your subnet mask. I'll give 255.255.255.0, which is to say that all the other devices I'm going to assign similar IP addresses for the first 3 digits, meaning they'll all have 192.168.1, except the last one will not be a 1, but it will be different. Okay. However, for the router itself, it's going to be a 1. Then I'm going to hit enter, like so. Okay. Then once done, I'm going to say no shut to append everything. Okay. And enter. Okay. You'll notice now that this turns to green. Okay. If you want, you can speed up the time so that that goes to green as well. Okay. And now what we're going to do is we're going to configure for this arm as well, for that interface rather. Okay. It's already on config F, so I'm going to exit to go to the previous. Now it's actually on config. Then again select an interface. In this case, the interface that I'm going to select is GIG001. So that's gig 0/0/1, like so. Okay. Then I give an IP address like I did before. IP address. Okay. We give it an IP address, and this IP address, it should not be the same as the other interface. So I can give this one 192.168.maybe.8.1, and of course you need to give it a subnet mask, like so, and then enter. Okay. Once you're done with that, once again no shut to append the changes. Okay. And that is it for that router. Okay. We can speed up the time so that orange acknowledges it. So there, speed up the time, and voila, all the pieces are green. Issue now is, if you hover over these, you'll notice that there are no IP addresses assigned to these PCs. So I'm going to statically assign IP addresses by going to the desktop and the IP configuration. Once I'm there, remember the IP addresses that I gave. Here I had 192.168.1.1 and a subnet mask of 255.255.255.0. So the IP address that I gave should have .1, but the last digit should be different. 192.168.1, and the last digit can be different. I can give it .20 or anything that I prefer. Here for the subnet mask, it normally states that automatically. Then for the default gateway, you are going to have the IP address of the router in this context, which is 192.168.1.1. Okay, and if you saw, this is how we configure the IP address of that router in this network. That was the IP address that we gave it. Okay, perfectly fine. Then I can close this off, and I can proceed to do this for the other networks. Okay, desktop, do the very same thing, 192.168.1. And then there's something else, say 30 or 39 if you'd like. Okay. And of course, the subnet mask does it on its own. Then 192.168.1.1 for our default gateway. And we proceed to do this like so. Same thing for that device. We do the very same thing. IP address 192.168.1. We can give anything for this, say 75 at random. Subnet mask automatically sets itself up. Okay. Then the default gateway 192.168.1.1 was for that router, and that's it for this network. And then we proceed to do the very same thing for the other network, which is this one. Okay. So for that network, we'll select that. And if we recall, for this interface, we gave .8 something else, right? I'll do the very same thing there. 192.168.8 for this one. Remember, .1 was this. .8 will be for that one. .8 dot. Then I can give anything out like, say, 123. Okay, and subnet mask is automatic. The default gateway 192.168.1, not .1, it's .8.1. Because this I gave .8.1 for the ending. Okay, and then we'll close that one off, and we do for the other device, which is this one in this case. So once again, 192.168.8 dot something else. I can say 45, for instance. Okay. Remember, I'm not allowed to give IP addresses that are similar to devices in the same network. Okay, 192.168.8.1 for that device, like so. And the last is this device, desktop IP configuration, 192.168.8 dot something else. I can say 30. Okay. Oops, 192.168.8.30. There we go. Subnet mask is automatic. Default gateway 192.168.1 or not .1, .8.1. Okay. Fair enough. Now we have given the configuration for each of those devices. Let me speed up time like so. Okay. Now we need to check if these PCs can talk to each other within the network, and then we'll later then check if they can connect across the router. Okay. So let's see. For this device, okay, let's do this. We're going to see if this device can talk to that device. The IP address of this device is 192.168.1.39, which I'm seeing while hovering over across. So .39, I'm going to send a ping from this one to that one. So I'm going to send the ICMP requests, okay, across to that device. So I'm going to ping 192.168.1.39, which was the IP address of that device. As soon as I hit enter, I should be able to get responses, which is perfectly fine. 0% loss, everything was able to be sent across. That's one way of checking if that configuration is perfectly done. Or you can use the simulation in Cisco's Packet Tracer by clicking on that message button. You click onto that and then the destination. Okay. And then you swap this into simulation mode and you hit on the play button. Your message should be able to end up where you sent it, like so. And voila. Okay. And you should be able to check it once it has reached its destination. Perfectly fine, isn't it? Yes. And then it should be able to return back to where it came from, like so. And that's how we know it ticked, so it's perfect. The message has arrived. Okay. So we know the configuration happens from that device to that other device. Okay. Let's see if this device can maybe communicate with, say, maybe this device. Okay. The IP address of that device is 192.168.8.123. So let's try and ping that device. Okay. So I'm gonna ping 192.168.8.123. See if we can ping it. Can we? Request timed out, and we actually do have responses. The 25% loss, but that's due to time anyways. If you rerun that ping, you will notice that it will be able to send those packets 100% all the way through. Okay. And again, ping is not the only way to check. If you're able to do that in the Cisco Packet Tracer, you can use that simulation tool from there to that device, and then we'll go into simulation mode and then hit the play and see if that message is able to get to where it's supposed to, which is there. Okay, so yes, everything goes there, which is that message now. Okay, notice the color, the dark one. Okay, it goes to the router, should be able to then go to the switch and then that device. Okay, let's see, and voila, it arrives perfectly sound, and it should be able to reroute back like so. Okay, anyways, that's how we configure the router and configure to ensure that the entire network works perfectly fine. Okay, anyhow, back to the theory here. Now we know how to resolve this little issue that we had from the New York and the Tokyo brand issue. Okay, we know how to now configure this part and assign IP addresses to those statically. We will see how we can make use of dynamic addressing, okay, by making use of DHCP. But anyways, that's something that we're going to see quite a little bit later on within this lesson. So moving on. Okay, so here, in terms of network connections, we have two types of network connections, isn't it? We have wireless networks, and then we have wired networks. Okay. And we remember that networks are spanned over a distance, isn't it? And we use entities that are called nodes in order for us to transfer or transport messages across different nodes or different devices. Yeah. Okay. And again, networks can either be wireless or they can be wired. In terms of wireless networks are basically networks where we do not require cables. However, we make use of radio frequency or radio waves in order for us to transmit those networks rather than using a cable, like a copper straight-through cable or a telephone cable, and so on and so forth. Wireless networks adhere to a certain standard, certain rulebook called the 802.11. Okay. And this is set up for pretty much all wireless devices. Okay. In terms of security, one can argue to say that wireless securities can have a trade-off compared to the wired ones. Okay. However, in terms of cybersecurity, wired networks are in fact more secure than the wireless securities. This is due to the fact that in order for hackers to hack you, and you are using a wired network, they have to be physically present in order for them to do this. So it kind of takes away the anonymity and it has them implicated physically. Okay. However, wireless, it can happen from anywhere. Okay. So as a cybersecurity analyst, even though you are working with wired networks, you do not say that you're going to just plug in the network devices and that's it. You also have to focus on the physical aspects if you are working on a wired network. You have to look at the physical aspects of your networks. Okay. Things like barricading. Okay. And how do we perform that barricading? We make use of things such as fences, biometric locks. We can block things like the memory ports or the USB ports on all the computers in a lab per se. We can block the USB ports such that you're not able to plug in USBs because we can have viruses that can spread through USB. So we can block those USB ports. Okay. Simple things like security personnel, the manpower, the security guards that walk around with whips or whatever that is, okay, or CCTV cameras. Those are the simple pieces that can secure the wired networks, okay. And of course, there's more to this. Okay, it's not only these that I have listed. However, for someone who is secure or setting up a security infrastructure for a wired network, you have to keep those ones in mind and consider them as well. Okay. When it comes to now wireless networks, it's taken away from the physical aspect, and we're then now focusing on the wireless part of it. Okay. The issue now with wireless authentication or logging into a wireless network is that passwords are actually passed out through the air, and they can be intercepted and they can be collected. Okay. We'll take a look at those kind of attack vectors. However, just keep that in mind. Okay. And when you're logging into a wireless network, there's something called a wireless handshake that is executed between you and the router. Okay. And these wireless handshakes can either be two-way or four-way handshakes. And we'll take a look at these when we look at different types of wireless security protocols. Okay. The first wireless security protocol to keep in mind is known as the WEP. The WEP stands for Wired Equivalent Privacy. And this is a flawed method of encryption. It's used in much older wireless devices, but it's still in support and it's still running. Okay. And Again, we said wireless networks transmit through radio waves. Okay, but these can be intercepted, as I've mentioned. So to show you this somewhat graphically, here is what to note. Okay, so here's you per se, and let's say this is the wireless router. Okay, this is the wireless router. As much as you are able to communicate and send traffic directly to this, we can have a bad guy that can intercept those stuff. Okay, so this cannot end up there, it can actually end up there. So we can actually intercept those radio frequencies. Sucks, doesn't it? But anyways, it's a trade-off. Okay, in WEP, all these messages that are being sent to the router are encrypted. They are mixed around using a certain key, and this key is of 64 to 128 bits. And this is the flaw in the design, because it's the same key that is used to encrypt literally every message that passes through. Okay, we use the very same key, and in some cases you can find that the Wi-Fi password is actually that encryption key. So if you think about it, if I know the Wi-Fi password, then essentially I can intercept these messages and just decrypt them using that key. Okay, and this is what we call a snifed attack vector, which is basically just sniffing. Okay, which kind of sucks, but that was the flaw with the WEP model. Okay, and this is how a sniffed attack looks like. You have someone sending traffic to a destination, but then there's the bad guy. The bad guy now will appear as the web server. So he'll say, hey, I'm the web server, and you'll say, okay, cool, here, please log in for me. And then before you know it, all your messages have been received. Okay, anyhow, the fix to this from the 802.11 guys was they decided to introduce WPA2. Okay. WPA2 was a better way of fixing that. WPA2 was then to improve to address to that flaw of the WEP. It uses something known as the TKIP, which is Temporal Key Integrity Protocol. So this is to say there's you and there's the access point. And we did say if you're using WEP, all the messages are sent off, but they're encrypted using one key. However, for WPA, we are instead using temporary keys. So the first time I send a message, a different key is used. The next time I send a message, a different key is used. A different key is used. So even if you intercept one, you do not have access to the others because it changes every time. And this key is a 256-bit key. So a different bit key is used each and every time. So you can say, yes, that's perfectly fine. I mean, the security flaw has been addressed, isn't it? However, it has not been addressed. That's due to the fact that this is still open to something known as an evil twin attack. How does an evil twin attack happen? Well, let me show you an instance. So here, this is you, and this is the wireless network, okay, which is perfectly fine. That's the wireless network. So you, right now, you are connected to the wireless network. Then there's me. Okay, there's me. What I'm gonna do is, I'm gonna tell you that I'm the Wi-Fi router. And then you're gonna be like, oh, snap. Okay, let me disconnect from him, and then let me connect to you. At that point in time, I have a wireless access point that has the same name as the original Wi-Fi network, same MAC address, same everything. You're gonna connect to me. What's gonna happen afterwards is you are now transmitting everything to me. Remember the handshake I spoke about to say when you've logged into a Wi-Fi network, you're going to be sending a handshake. You're going to be sending your password, basically, encrypted or not encrypted. You're going to be sending it directly to him. That's exactly what's happening here. As soon as you're saying, oh snap, you are my actual Wi-Fi network, here's the password, please log me in. And before you know it, I have that Wi-Fi password. Which kinda sucks, but that's evil twin, and that's how it works. And people can take this a step further and say, you can improve that attack vector from being a simple evil twin to being a evil twin with a man-in-the-middle attack vector to it. How would it look like? Well, this is to say, we proceed with the very same connection. You're now connected to me thinking that I am the Wi-Fi network, and then I connect to the original Wi-Fi network. Now I mediate between you and the wireless access point, or the internet is somewhere here, so you can actually connect to the internet through that wireless router. So this is now to say that all the traffic that goes to that wireless router passes through me, and I have the ability to modify any and all of those wireless or any of those packets. Let's take a simple instance. For example, you go to Facebook, you log into your Facebook account, your password is sent to me first before it gets to that one, so I'm able to read it. Here, I'm also able to modify them, yes? Suppose I open up a bank and then I'm sending money to somebody else, yeah? I go to that field and I type in my account details, yeah? Whoever I'm sending the details to. This is essentially sent to the router, isn't it? But this time the router is me. So I see that and I decide to modify that account number. And I can put my own account number and actually send it to the wireless router itself. So now instead you're actually sending money to me. Then the router will say, cool, perfect, the transaction is complete, it's sent to me. And then I say, yes, the transaction is complete, sent to me. That's what is known as the man in the middle attack, which starts off with an evil twin attack. Okay, which kind of sucks, but again, trade-off. So would you use WPA? Well, yes and no. Rather use the improved version of WPA, which is the uncle WPA2. WPA2 uses pre-shared keys. Okay, can either use the advanced encryption system or it can use the pre-shared keys. Both of them are secure, so you pick which one you'd like to use. For a personal network, the best idea is to use a PSK. For a more enterprise network, you can use the AES. Okay, for businesses like restaurants and so on and so forth, they would prefer to use that AES encryption kind. So you'd be using WPA2 AES if you were working for a business. If it is your own personal network, you can use WPA2 PSK. Okay. Here, how do we secure those wireless networks? For the wireless networks, in order for you to secure them, it's very simple practices, things such as disabling remote access. How do we disable remote accesses? This is something that is built in into the wireless router. In fact, you'll see one of your assignments for the week. It has to do with disabling that remote access, hardening the security. Okay, but the whole concept of disabling that wireless access is to say, here we have a wireless router, okay, and then we have two devices, okay. One of the devices was allowed into the network, and the other one just hacked his way through. After hacking through, okay, so this is the bad guy. He decides to hack this guy. He's able to do that, but if this guy, the router, says no communication should be allowed through me within the network, unless you're communicating with the internet, that's perfectly fine. So you can set that up. So if he tries to send some nonsense stuff to this guy, this one will not allow that to happen. That's how a remote access list works. Okay, and you'll notice that in your assignment, it will actually lead you through how to set up that remote access, as well as this one known as the access control list. So one thing we need to know now is every device that can connect within the network, yes, it's given an IP address, but additional to that, they have a MAC address, which is something like a fingerprint. So you can say devices with the following MAC addresses are allowed to connect. If you don't, then you're not allowed to connect in. That's how an access control list works. It works by means of using that MAC address. Okay, but then again, this is something that you will see in the walkthrough assignment. Okay, another thing you can do is to keep your firmware up to date. The software that was used to build your Wi-Fi router, keep it up to date. Normally does this by default, but it's a thing to put into practice. Update this every now and again. Okay, regularly change your ESS ID. Okay, so what we mean by the ESS ID, we're talking things such as the name of the network, okay, your Wi-Fi name. It's something that you may want to regularly change as well. Okay, another thing you can do is set up a segregated guest network. I'm sure you may notice that modern routers can have two different networks. You can find that there's a normal 4G network and there's a 5G network. That's something that you can put into practice. Those who are visiting, or guests rather, would connect to a guest network and you are segregated from them. Okay, that's another thing to put into practice. and by so doing you can up the security of your wireless network. Okay, added on to that, we have something known as an IDS, or an intrusion detection system, and this is a device or a software. It can either be two. Okay, in terms of it being a device, that's a firewall. In terms of it being a software, we actually have this kind called Snort. So what these do is they monitor all the network traffic. Okay, they sniff for that network traffic, and they're basically looking for malicious activity. Okay, most of these are actually equipped with artificial intelligence to actually study some of these. Okay, they study the network, they study the traffic, and they know what to block and allow in. We'll see how to actually install a special one known as an ASA firewall. Okay, this is how an ASA firewall looks like. It's an actual device that you plug into the network, and normally we actually have this between we actually place this like right where we would like it to start detecting. That's an ASA firewall. Okay, we'll see how we can actually set up that ASA firewall. ASA, by the way, stands for Adaptive Security Appliance, for those who are unfamiliar with it. Okay, it just means that it adapts as things go. Okay, so that is it theoretically. Let's get back to the Cisco packet tracer. This is the network that we just set up like just now. Okay, I'm gonna set that one aside. Let's first take a look at how to install a firewall. Okay, how do we install a firewall? Well, to set up a firewall, this is what we're gonna do. We're going to build an individual arm like this one, and then we'll have a firewall placed somewhere right around there. Okay, in place of the router, we're going to place a firewall. Okay, so this is how it will look like. So I'll have two PCs. I'll have PC1, maybe I have another PC, and another PC, like so. So I've got three PCs. And remember how we can interconnect these PCs? We can make use of a switch. I'm gonna grab a switch and place it there. And now I can interconnect these devices like so. Remember then again, everything you do in Cisco Packet Tracer is a simulation of real life. So master that Cisco Packet Tracer. Okay, so there we go. Everything is then interconnected, yeah? And remember, the gateway between you and the outside internet is a router. Okay, but instead of putting a router, what I'm going to do now is I'm going to place a firewall. A firewall acts as both a switch and a router, but now I'm going to make it work as a router in this case. Okay, I'm going to grab a cable and do it like so. Okay, so now that it is right there, remember we said IP addresses can be set up statically or dynamically, right? So now we're actually going to take a look at how we can set up dynamic addresses rather than making everything static. Okay, so now you'll notice after making this connection, yes, this part of it works fine, but this doesn't work. And we saw this quite similar to the router, isn't it? We had to configure the router. So we're going to configure this firewall. If you see how the firewall looks like, we're going to configure this firewall so that it works as a router and as a firewall. So first things first, when you open this, you notice we're working on Cisco ASA. Okay, we are going to configure now this to work with DHCP and as a firewall. But first, we're going to configure this firewall as if it was a router. Okay, and if you recall us configuring routers, we first enable the router. Yes, you'll notice it's requesting for a password. By default, we don't have to put in anything, so I'm just gonna hit enter because they do not have a password by default. Okay, after that, we said config T or configure terminal. Okay, so that I configure this from the command line interface. Okay, then I'm going to select a interface. Okay, and note the name of the interface here is gig11. So that's the interface I'm selecting. So in this case, my interface is gig 1/1. Perfectly fine. I've selected the interface there. Okay, then I need to assign an IP address. Remember, I'm configuring it as a router, not on the firewall part of it yet. Okay, so configure the IP address. Let me give it say 192.168.8.1 for instance. Yeah, and then of course you need to give your subnet mask, say 8.0, like so. Okay, then I'm going to give a name for this network. Okay, let me call this New York. So New York. Okay, name New York. So I give it a name. Okay, and then I need to set up a security level for this firewall now. Okay, how do I do that? I'm going to just say security level. Now, in terms of security levels, they range all the way from 0 through to 100. And well, because this is my home network, I'm going to give it the highest security possible, 100. Okay, like so. So perfectly fine. Now the security level is sitting on 100. Okay, then I'm gonna exit out of the interface. Okay, all I've been doing so far was configuring this interface. Okay, the security level for that interface and everything else, the IP addresses and so on. Now I am configuring it as a firewall, as a DHCP server. So how do I do this? First, I need to enable my DHCP service. To do this, I'm going to say DHCP. Okay, I'm going to give it an IP address as a DHCP server. Remember what DHCP service does? Well, DHCP service is responsible for allocating IP addresses to the devices in the network. So, DHCP address, I'm going to make this to allocate IP addresses from 192.168 dot. Okay, remember the dot 8. Yes, dot 8 dot. Let me say I want it to start from 10. Okay, all the way through to 192.168 dot 8 dot, say maybe 120. Okay, and then I need to give the name of the network that I'm assigning this DHCP to. In this case, it's New York, like so. Fairly fine, isn't it? Good. Now I have configured my DHCP service. Then I need to do the DNS, okay, the domain name server. So to do this, it's more just DHCP DNS, and the IP address of the firewall itself, which is just 192.168.1.8.1, just the IP address of that firewall, and enter. Okay, and then that's all that there is to it. Then I need to enable the DHCP, because all I've been doing now is configuring and configuring and configuring the whole time. Now I need to enable the service now that I've configured it, so that it shows me the changes and everything else. Okay, so how do I do this? DHCP enable. Okay, I want you to enable for the network called New York. Voila. Okay, I have raised it up. You're probably like, yeah, but Nesh, this hasn't worked out yet. How do we fix that? Okay, to do that, we now have to say no shut. You remember this for the router? The very same thing applies here. Okay, oh, before I say no shut, I actually need to exit and then no shut, like so. Okay, oh, I need to, yes, let me write the changes. Write me. Okay, yes. Then we actually need that no shut. Oh, yes. Let me config config T. Yes. Configure back to the terminal. Yes. And then let me select that interface. Okay. Let me select that interface. I'm still working in GIG 1/1. Okay. Oops, not 1 I forgot the slash. Yes, 1/1. So then let me no shut this one. Okay. So now that's to up that port. Okay, you'll notice now it's actually green. Okay. Now that it is green, it is up and running. Yes, it's yellow there. We can just speed up time to fix that. Okay. What's missing is we need to assign IP addresses to these PCs now. Do I have to do this statically? No. I can do this dynamically on the IP configuration. Of course, by default, it's on static, but I'm going to put this on DHCP. And DHCP request is successful. That has an IP address now. Let's check that one out. Desktop, IP configuration, the DHCP should be able to successfully do that for all the other devices. Okay, like so. IP configuration, use DHCP, and voila. Okay. So we got some IP addresses from the firewall, perfectly safe. Now the question is, can the devices talk to each other with those assigned IP addresses? Let's try the network simulation. Do this, do that, and this is successful. So kind of works fine, doesn't it? We can run that simulation. We can speed it up as it goes. Okay. You can do that like so, yeah. And voila, it actually does arrive. And it must send back the same information and the same data. And it should check if that's successful. Voila. Beautiful. We know how to configure a firewall as a DHCP server. Perfect, isn't it? Okay. Now the last piece that we need to learn is our sniffer. How do we configure a sniffer? And what is a sniffer exactly? Well, a sniffer is just a device that captures traffic between networks. Doesn't sound that big, does it? Yeah. Let's configure that. Okay. So this is what I'm going to do. I'm going to copy this out as it is. I don't want to reset that again, but the setup is very much the same, but let's do this. Okay. I'm going to give, let me just give one PC. Of course, you can set up multiple PCs. Okay. I'm going to have a switch like so. This PC will connect to that switch, and then we'll have a router. Okay. These part you know how to do. But now for this to get to another network, I'll have another network. Just gonna drop down the devices all at once. Okay, there we go. But I would prefer that this network is a little different. Okay, I want to capture every message that passes to go to this network. So in order to do that, I'm going to install a sniffer. You'll find this in your end devices, by the way. I'm going to place a sniffer right in between. Okay, let's hardwire everything. That to that, this to that, and this. Before it gets into the network, it needs to pass through the sniffer. So a sniffer is like an actual device, by the way, like so, and then this to that. Okay. But you may notice a little issue that we have is this part with the router. We need to actually configure the router. Okay, and no for that, and enter to get started. By this point in time, you know how to configure a router. First, enable it. Okay. Specify that you want to configure with the terminal by saying config T. Okay. Then select your interface. So I can say int. Okay. Select the interface. Let me configure this network. So that's gig 000. Okay. So I'm going to select the interface gig 0 slash, oh, not 1, 0 slash 0 slash 0. Like so. Okay. Then I'm going to assign an IP address to it. So that's just IP address. Okay. 192 say.168 say.1.1 and give a subnet mask to it like so. Okay, and that's all that there is to it. I can write to memory. Okay, so let's write this to memory. Oh, I can't do that. I have to actually exit out of this first, but actually let's say no shut. Okay, so now it has written it. You'll find that the ARM is different. Okay, I wonder if this can work as a DHCP server, by the way. DHCP. Does that work? No, it can't. Anywho, that's fine. That's perfectly fine. We have configured for this ARM. Now we need to configure for that ARM too. Okay. So let's select another interface. Say this is interface gig 0/0/1. Okay. I've selected that interface. Then I need to attach an IP address. This part you are quite used to by now. 192.168.8.1, let me say 255.255.255.0. Okay. And then what do you do after that? Well, no shut. Okay. Now that ARM is green. Perfectly fine. Okay. Alright, let's give IP addresses to the other devices there. Okay, there. IP configuration 192.168. We say these are .1.1, isn't it? So say .1.45. That MAC address, that's fine. That's for the default gateway 192.168.1.1. By now you know that this is the IP address of the router for that interface. Okay. Perfectly set up. Fine. This one is done. Then we do the same thing for that device too. Okay. We do this. The desktop configuration. Remember, these ones are .8, isn't it? So .8 something, say maybe .100. Subnet mask is perfectly fine. Default gateway is the IP address for this router for that interface. So that's .8.1. that may have been a little bit fast, so you might want to return back to look at how we configured routers. Okay, anyways, that's not the main deal. Let's just see if we can have communication between this and that one. Can we have that? Let's see. Message goes there, and then it should be able to go to the router, and then the router should be able to take it to the sniffer. Now this part is where the sniffer captures that message and records it before it goes to its destination PC. Okay, we're going to see that part in a few. Let's take a look at the sniffer. If you look at the sniffer, the sniffer looks something like this, just the in and the out. That's all that there is to the sniffer. Okay, if you get to the GUI, you'll notice some stuff there. Okay, that's perfectly fine. Okay, what we want to do now is we're going to go to one of the PCs. Say we're going to go to this PC and we're going to try to ping this PC. And ping, if you read up on ping is a ICMP echo request. It's an ICMP type. So are we expecting our sniffer to actually capture ICMP, something similar to this? Okay, so let me do this. Let me get rid of all these. Let's clear all of those ones out. So we're actually empty, isn't it? So here the IP address of that one is .8.100. So I'm going to go to this PC. I'm going to open my command prompt and I'm going to send a ping to that PC just to see if the sniffer can actually capture that. So I'm going to ping 192.168.8. We said this is .100, isn't it? Let me just double check that. Yes, it is .8.100. Okay. Let me ping it, and perfectly fine. So here we managed to send 1, 2, 3, 4 ping requests. So we're expecting 4 ICMP echo requests. So let's take a look at the sniffer and see if it managed to capture those 4, and perfectly fine, it captured those 4 ICMP messages. Now you don't have to know how this does this as of yet, but that's the whole concept and that's the whole idea. In real life, the sniffer, it looks pretty much like that as it looks physically from the back. Okay, but anyhow, that's how sniffers work in terms of packet tracer. But these are sniffer devices, isn't it? What about sniffing software? We do have softwares that can capture those requests, isn't it? So because we love Linux in this entire course, it's all about Linux. So in your Linux, okay, this is not important, this is just kickstarting for the upcoming week. You're going to be using a special tool called tcpdump and Wireshark. So this is how we would be installing tcpdump. So sudo atp apt install tcpdump. tcpdump is a special tool that we actually use to capture those network devices, just like a sniffer does. We're sort of turning your local PC to a sniffer. Okay, but it seems I'm not quite sure if I already do have tcpdump. Let me see. tcpdump. Oh, I actually do. So if I want to do this, I would say sudo tcpdump, and then I would specify which gateway I would like to detect on. So in this case, if you say iwconfig, you will notice that the Wi-Fi I'm currently connected to is WLO1. Yeah, so WLO1. Okay, there we go. You'll find expressions sucks. Okay, let me just do it by default, like so. You'll notice when it does this, there are a lot of messages that are passing through. Yeah, let me just Control-C to stop so we can allow ourselves to process what is going on. So if you look here, let's say this packet, for instance, there's a message coming from Akamai Technologies, which is directed to Melissa, and Melissa is my laptop in this case, so that's perfectly fine. These are just messages anyways. There's something coming from the gateway, which is my Wi-Fi network, to Melissa, which is my laptop. You know, these are kind of messages that you can detect, isn't it? Okay, that's tcpdump, but then again, you don't have to know how to use it as of yet. Okay, another one to look at is known as Wireshark, which is this one. You'll be shown how to install it next week as well, so not exactly as important, but that's Wireshark. So let me just show you how Wireshark looks as well. It works very much the same way as tcpdump. Okay, so look here, we have a Cisco remote capture, but anyways, that's not exactly as important. But when I get to this part, I'm basically looking for a device that that has some traffic going through it. You'll notice that mine doesn't. Okay, but here you can select. So when we run this with admin privileges, you'll actually notice that you'll have your wireless network show up there. So let me show you how this works. So I can say sudo Wireshark is actually the right way to execute it. With admin privileges, there is my Wi-Fi device. You can notice that there's some activity going on the Wi-Fi, even Bluetooth as well. You can sniff over Bluetooth, but in terms of Wi-Fi here, now it's actually reading some stuff that is passing through the network. Let's do this just to stop that transmission. You'll notice here there's the source, who's sending the message. This is the IP address of whoever is sending the message. The destination is whoever is receiving that message, and the message you'll most commonly find it somewhere here. Okay, but anyways, this is for that upcoming week. We'll show you how to install Wireshark, but firstly how to install Linux, special version of Linux called Kali Linux, which we'll be using. But then again, that is for the upcoming lessons, and that's from lecture 4 going onwards. But I hope this assists you, and of course, you know how I am. You do have assignments for the week. You will find these in the war room. They've already been uploaded up for you. Okay, just to show you what is to come for your assignments. Okay, so for your assignments, of course, I'm gonna go there and log into my war room account, Rise Academy. You log into your war room account. This is Cybersecurity Analysis. If you go there, under your practical, building networks and hardening security, you'll find it there. You've got 2 assignments, of course. You've got building and configuring a network, and you have hardening Wi-Fi security. You've got, 6 days from date. Okay, so you'll find this one where you actually have to build a complex network. Let me show you how that complex network looks like, by the way. So you're gonna download that file and actually open it. You're probably like, what file is he talking about? This file. Okay, so let me show you. I've already downloaded the file, of course. Desktop, Rise Academy, and there it is in Packet Tracer Labs. Okay, this is the file that you're given. Okay, you'll open it, and this is how the assignment actually looks like. This is the Wi-Fi network that not the Wi-Fi network, the wireless network that you're building. Each and every bit of it, you're building it as it is. The names of the Wi-Fi networks, or rather the names of the devices, the names of the interfaces, everything else. Okay, and take note of the IP addresses, isn't it? The Madang distribution has to be given IP addresses like this. This is the Madang distribution. Okay, and the Lai distribution, which is this one, should be given those IP addresses, which is those devices basically. Okay, I know we gave you that. Okay, but just disregard that. Okay, disregard those. Okay, just take note of the IP addresses that you're given. Note, you are not permitted to use the logical window or the GUI. Okay, not the logical window, rather the physical. Okay, the GUI, we mean in terms of your router, you are supposed to use the command line interface to configure your routers like so. Okay, good luck with that one. Of course, after you're done building your entire network, you go to then save your file, and then that's the file that you will be handing in on that once you click hand in. The other one is just going to walk you through. This one is not a big deal because it actually walks you through how to harden a Wi-Fi security, but that is another assignment of its own. So good luck with those assignments, and of course, if you guys have any questions on those assignments, do not be afraid to reach out, and I will see you guys in the next one.